This is part of a series on web encryption. I'm going to try to explain this using layman's terms as much as possible, but clearly the average person does not really understand how web encryption works. I'll do a rehash of explaining that briefly. The issue I want to focus on today is how we are being fooled with the belief that certificate authorities, the parties that authorize and validate web certificates, are trustworthy. They are not. New changes have just occurred, and unfortunately it means that so many governments can now directly spy on your traffic, even outside the jurisdiction of those governments. In plain English, I'm telling you that HTTPS, or what I just generically call web encryption, is completely broken. Someone can read your internet traffic and break the encryption, all because of the stupid and untrustworthy system called the Public Key Infrastructure, or PKI, that has, to be honest, been waylaid by stakeholders more interested in mass surveillance than your privacy. I did a recent video on web encryption, but new events in the EU have now put this into a crisis status. This is a very big issue, and in a later video I will actually go into my answer on how to solve this huge dilemma by discussing a redesign of the whole PKI methodology. Hopefully one of those big browser companies will listen, since it will benefit them. In the meantime, I will focus on a single uncorrupted element of the public key infrastructure, and that is the free provider of web certificates, LetsEncrypt. If you're a user, feel safe when you go to a website that is powered by a LetsEncrypt certificate. If you're a website owner, you should stop going to a third party to get a website certificate. Instead, use the free one from LetsEncrypt. This organization is a lifesaver and game changer, and came in at the right time. Let me explain this web encryption morass and how LetsEncrypt will provide us with a safe haven on the internet. So stay right there. First, let me go to my website, brax.me, and show you the site certificate. You will see here that this site is using a certificate provided by LetsEncrypt. As I will explain in this video, the fact that I can see LetsEncrypt here means that this is a safe website. There's no man in the middle, and the encryption is intact. Let me go through a deep explanation of the problem facing us if a certificate is not from LetsEncrypt. The public key infrastructure is made up of various levels of certificate authorities. The job of these authorities is to distribute website encryption certificates. These certificates are made up of a unique pair of public and private keys. These are just plain text files that have content like this. These certificates serve two functions. First, the public and private keys provide the encryption keys for something called asymmetric encryption. This is an encryption method based on no prior knowledge between two parties. This special method is what powers the website internet encryption today. The second function of the certificate is to validate the entity. If the certificate is supposed to be google.com, then the certificate will state the entity on the certificate. And this will be mathematically validated by a unique digital signature, which can then be checked against the digital signature of a certificate authority. Certificate authorities are supposed to be trusted, and thus you would trust that the website is in fact google.com as it states. Now, what happens though is that if a certificate authority is untrustworthy, they can issue a certificate with the domain google.com and have it controlled by a party that is not in control of google.com. Because it is a new certificate, it will have its own private key, which will be in the hands of the party authorized by the certificate authority. Let me state this important technical detail. Whoever has the private key to any certificate can decrypt the traffic using that certificate. By doing this, this party can impersonate google.com and can intercept and decrypt traffic. They can then forward your traffic to the actual google.com, so you will be none the wiser. By the way, certificate authorities are nothing more than root certificate public key files pre-installed on your device. Anyone can call themselves a certificate authority simply by installing a root certificate on your device. And the operating system is complicit in making you think it really is a valid authority. For example, something I mentioned in a recent video is that all Microsoft Windows computers have a pre-installed root certificate from Microsoft, even though Microsoft isn't really a true certificate authority on the internet. Here's a list of root certificates pre-installed on a Windows 11 computer, and you can see Microsoft on there. This enables Microsoft to basically spy on any Windows computer and surveil any web traffic. The supposed reason for the Microsoft root certificate is to validate apps with an app signing mechanism for Windows developers. But there is no restriction for how this root certificate can be used. That is the main flaw here. Now here's the real bad news. The EU has decided that it wants to issue web identities for every resident of the EU. For this purpose, they will require that an EU root certificate be installed on every computer. It gets worse. The EU will then distribute intermediate root certificates to each EU country, so each of those countries could then themselves behave as a certificate authority. Here's the additional layer that will truly zuck all of us. The EU will make it illegal for any browser to untrust the EU root certificate or its intermediate certificate authorities, meaning the countries it has authorized. So you can't remove it without violating their laws. Wow. Do you understand what this means? It means that any country in the EU can then create a fake certificate for any domain in the world and spy on anyone in their country. Okay, that's probably being done now anyway, but here's the kicker. There's no reason for these fake certificates not to work in any other country. This will work outside the EU since the browser will pre-install their root certificates. This is the stupid design of the PKI, people. Just to highlight this design issue, let me show you an actual event that demonstrates how screwed up PKI is. The original root certificate authority on the internet from the 1990s was VeriSign. This was back in the day when HTTPS or SSL was first invented. Decades later, VeriSign was bought by Symantec for an eye-popping $1.2 billion. Shortly after, Symantec bought an internet surveillance company called Blue Coat Systems. This company provided mass surveillance tech equipment to any government. The way they powered the surveillance was from fake certificates. Here's the example of the evil. Since both VeriSign and Blue Coat Systems were owned by Symantec, VeriSign granted Blue Coat Systems an intermediate certificate authority. This allowed Blue Coat Systems unlimited capability to create fake certificates, which then allowed decryption of any web traffic for whatever government used their tech. Except Google caught them using fake Google certificates. As a result, Google banned VeriSign and all of Symantec on Chrome, and this led to its breakup. Symantec has since been resold in pieces. VeriSign was sold to DigiCert. This evil was swept under the rug by Wall Street, and now the name Symantec is no longer used. The remaining entity in Symantec is now NortonLifeLock. The warning I state to you is that what VeriSign did with Blue Coat Systems is now going to be emulated by the zucking EU, except this will be powered by a law that ensures you cannot question it. This makes us all very vulnerable. Because of the experience with VeriSign, it really makes me not trust any supposed authority that claimed to be trustworthy. The EU is going to force itself as a root certificate digitally, and of course, that is already forced upon people by many governments that require a root certificate to be installed on devices in that country. Every authoritarian country is already doing this. On top of this, you have entities like Microsoft and Apple who both have root certificates installed on devices they make. Also, did you know that all it takes to turn these certificates into deadly surveillance tools is for a certificate authority to reveal the private key of the root certificate to the government? Couldn't the US government demand this under the Patriot Act? And they have to not talk about it? You think you need quantum computers to break web encryption? This is the easier way. I've already described in a recent video how a fake root certificate is created by the Avast antivirus, which can then examine all encrypted web traffic on the device, thus creating a man in the middle. Now, fortunately, there is a last bastion on the internet where I feel secure that there is no man in the middle. And these are the websites that use certificates from LetsEncrypt. I showed you earlier that my site Braxme is powered by LetsEncrypt certificates. This is not something that solves the PKI encryption problem in general, but at least ensures that the platform you're on is safe from surveillance if you take the time to examine certificates. Why is this? Let me give you a little history of LetsEncrypt. LetsEncrypt was formed as a nonprofit in 2014 and is actually founded by EFF.org, the Electronic Frontier Foundation. It was formed to provide free website certificates. Well, this is now the largest provider of website certificates. I think the declared number is something like 300 million websites. The original goal of the organization was to promote the use of HTTPS in website, which allows easier transition to web encryption. By providing a free service, it removes the extra friction created for website owners to have to understand how to deal with paying for and installing certificates. But the hidden benefit of LetsEncrypt is how you set up a certificate using their methodology. I'm going to show you an example of how I would set up a web server and then install a certificate using LetsEncrypt. There is no person involved in the certificate granting process. You basically install and run their software on your server, and this then handles the negotiation and setup. In general, each website owner can set up their own certificate using the LetsEncrypt software, and this is easily done as long as the website owner has direct control of their domain via their DNS server. Once you understand the methodology, you will see that it should be practically impossible to fake this with some external entity trying to set up a server. What I will demonstrate here will look very techy to someone who has never set up a web server in Linux. But this is not about the details of the installation. I want you to observe the process and what is happening, because that reveals the strength of LetsEncrypt. There is no need to memorize anything I do here. So I'll start off creating a Linux server. In this example, I'm going to go to my Linode account, which is my cloud service, and set up a Nanode server and use Ubuntu as my OS. At this point, the most important detail is the IP address assigned by Linode, so I make a note of that. This specifically points to this new machine I just created. Next, I will go to my DNS server management tool, which in my case resides on Amazon AWS. I will create a DNS entry for this particular server, which I will call demo.braxman.com. By the way, I own the domain braxman.com, so I can control all the subdomains for this. This is an extremely important point. I control the DNS. The important thing to note during setup of this subdomain entry is that I specify the IP address of the server. In this example, it will be the address I got from Linode. So once that DNS entry is saved, if I go to the internet and find the server, it should always point to the server IP, which is the new server I set up. As you will see later, the way LetsEncrypt validates a server ensures that no third party gets involved, and that makes LetsEncrypt trustworthy compared to other website certificates. Now let me log into the new server I created. And the first thing I will do is install Apache 2, since that is the web server I will use. So I'm going to run these Linux command, apt update, apt upgrade, apt install Apache 2. If I type the IP address of the server on a browser, the test website page from Apache 2 will show me that the website is already running. I can also verify the same thing by typing demo.braxman.com. Now I will install and run the software from LetsEncrypt, which is called certbot. apt install certbot. Then I will create the certificate using this command. Now let me respond to the prompts provided by LetsEncrypt. The way this works, LetsEncrypt will independently set some validation text in my web root folder, which is var www.html, when using Apache 2. And here's how this operates. LetsEncrypt will independently verify the domain using its own DNS, and then it will see if it can reach the server to download this validation file. If it succeeds, you see it is successful, so it creates the certificates. Let me show you where the certificates are located now on this server. Let me describe a case where LetsEncrypt is not used. One of the ways someone can fake a web server is by DNS spoofing. For example, let's say you're the ISP on Kazakhstan. Everyone in Kazakhstan will rely on you as the provider of DNS services. In fact, even if some smart IT guy in Kazakhstan overrides his DNS on his machine to use, let's say, Google's DNS, the ISP can just override that anyway and force it to go through the Kazakhstan-controlled DNS. This is called DNS spoofing. This allows the Kazakhstan government to intercept traffic intended for demo.braxman.com and have it go to a government interceptor machine. So someone could always fake the domain demo.braxman.com in Kazakhstan if they wanted. They could even issue a fake certificate, since Kazakhstan enforces root certificates from that government. But with LetsEncrypt, this will not work. LetsEncrypt uses its own DNS. And since its internet infrastructure is outside of your server infrastructure, you cannot influence it with DNS spoofing. Thus, LetsEncrypt will only validate a domain which it can reach authentically. And to add to the difficulty of faking a LetsEncrypt certificate, the certificate itself is only valid for 3 months, which requires this certificate renewal process to repeat within that time period. It will do this automatically. So in summary, if you look at the certificate of the website you're visiting and you want to know if it is authentic with no man in the middle, you can always be assured of this if the website is one of the 300 million sites that uses LetsEncrypt certificates. If you see Microsoft, Apple, Google, or some EU or government certificate on some independent website, then that should be a warning flag to you that there is a man in the middle. If a website uses some standard certificate from normal providers of certificates like DigiCert or Komodo, or their intermediate CAs, the sites could be safe or not. There's no way to be certain. Do this check everywhere you go on the internet and just be aware of your surroundings. The internet world is not what it appears to be. I created a company to offer solutions to privacy instead of just talking about problems. The first important product is the Google phone. These phones are the primary tools for privacy protection. We have different models of Pixel phones which are using Calyx OS. There is no Google on these phones, and there is no Google ID, so they are invisible to Google. Most apps will work just fine as long as they're not from Google. These phones are around $400, so much cheaper than a regular phone. I started a VPN service, Bytes VPN, years ago. The thing about a VPN service is that you have to trust the provider of the service. So some of you choose to trust some unknown corporation with some unknown affiliations. Here's a VPN service from someone you know. My face is attached to this service. Me and my staff support it directly. Definitely no logging, and we do not block email, like many of them. Check it out. We have worldwide coverage, and we do not scam you with auto renewals. I created a Braxmail product from user requests of a stealthy email solution. The main claim to fame of our email products is that there is no metadata. We do not record IP addresses and ensure that IP addresses do not appear on your email headers. Thus, this provides you with a quiet way to gain privacy by not revealing where the messages are coming from. You get to use any of our 7 domains, some of which are very obscure, and you can create unlimited aliases. Sign up quickly to use the short usernames, which will be very popular for use with aliases. You can also use webmail, so no setup is required to use it. Just a normal browser will be fine. All these products are on the store on my app BraxMe. Sign up on there. Don't worry, you will not be asked to give any personal information to sign up. Thank you for watching, and see you again soon.